key moment to look at in 10 seconds
Attention
at T minus 40.
This is the final go, no go poll for operations. Raptor 1. Raptor 1's go. Raptor 2. Go. Stage
And
1.
we flew right
Go.
through that.
Stage 2. Go. Flight directors go for launch. Flight directors go for launch.
All right, we're now T minus 20 seconds until liftoff of Starship Flight 6. This will mark our second attempt to catch the Super Heavy booster at the launch tower. As well as
Top. Allumage 2 VCR, décollage.
4, 3, 2, 1.
Execute.
Ship engine startup.
Stage separation. Booster respect burn.
Novian 0, 30 seconds till catch decision.
Confirm 30 seconds to make that decision.
10 seconds till catch decision.
Hot stage separation confirmed.
Flight directors go for booster return. Operator go vote is set true. We are go for catch.
Go for
coming in hot.
And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T minus 17 seconds and counting. 15, 12, 11, 10,
I can't wait for us to hear the sonic
8, 7, Start. 2, 1. Booster ignition and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Booster now hovering as it aligns with the tower for catch.
Booster coming in.
See those trucks
Get
down
ready
to,
for that boom, Kate.
down to 3.
Super Heavy booster.
Villa has caught the booster.
Ship avionics power telemetry nominal.
Starship has entered the atmosphere. Starship is approaching the peak heating phase of entry.
Planning for startup.
Starship is on target. Starship has landed.
Bonjour. Bonjour les gars. C'est seulement maintenant que je me rends compte que j'ai lancé le live trop tard. Enfin trop tôt, je veux dire. Le live de SpaceX. Et pour... il est dans à peu près 20 minutes. Arrête. Comment on va faire là encore? C'est 48 minutes. Ok, attendez. Attendez, on va faire un petit truc avec Snaz. Pourquoi tu fais ça? Hop. Attendez. Et... Ah, voilà. Donc du coup, là, on a le compte à rebours. On a le compte à rebours qui vient de se lancer. J'aimerais bien voir ces... J'aimerais bien voir les images comme ça. Merde. J'ai commencé le live trop tard. Trop tôt, putain. Je confonds toujours. Qu'est-ce qu'on va faire? Je pense que je vais vous renvoyer à l'écran d'attente parce que là... Non, 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 ferme, ferme. Là, j'ai fait une grave erreur. Ça décolle dans... Enfin, le live commence dans 20 minutes normalement. Et je vais vous renvoyer à l'écran d'attente. Désolé pour... Tu peux arrêter? Attendez. Attendez. Hop, voilà. Merde. Voilà, du coup on se revoit dans quelques instants, dans quelques minutes, lorsque ce sera enfin le temps de commencer le live, parce que désolé mais là, on l'a commencé beaucoup trop tard.
Saying goodbye.
Yeah, the polite way of putting it, saying goodbye. Although I did appreciate, how do they pick which one bites the dust?
Well, this one will bite the dust, but it won't so much bite the dust as it will swim with the fishes.
Gonna be swimming with the fishes after this.
What's interesting is this is actually not the oldest booster that they have in the fleet, right? So you would think that maybe it will make more sense to get rid of the older one. But it's actually not. And we thought at first this was going to be flown on B1069, which is ironically also on a 21st flight, but it's older, right? And it also had some damage on its first flight after landing because of rough seas and everything. So it's quite interesting, right, that they chose B1073.
Now, if only we had some insight into what the qualification process was for refurbishment and reflight, but like you said, I mean, it could very much just be that maybe 1069 had a little bit more wear and tear on the joints. Maybe it would have needed engines switched out in order to achieve, you know, the dynamics that you need for a launch of something this heavy. Maybe this booster's just fared a little bit better in the end, and they feel it can handle that long-range yeet.
Or the opposite, that maybe it fared a little bit worse on a previous mission, and this one's technically showing more age than a slightly older by years one.
Good question, though.
Very good question. Yes, and unfortunately the answer is SpaceX doesn't tell us. So it's gonna have to be best guess there. The Coefficient, thank you for becoming a AdRap member. And then Roseanne DeVasto with the question, who has the over-the-parking lot shot? We do. That is one of our remote cameras that we have at the Kennedy Space Center press site there. So yes, that is one of our remote cameras. Typically we have it pointed at one of the pads or something a little more zoomed in, but for these launches. It's cool to kind of get a wide view of all of the people in the parking lot, all 6 of them. Well, we are now under 40 minutes to go until the scheduled liftoff of this mission. Alex, do you mind running us through kind of the timeline of what we can expect now in the next 39 minutes and 15 seconds here?
Yeah, so right now, if they're still on track for the opening of the window, remember this is a 2-hour window that opens at 8:34 p.m. Eastern. That will be 134 UTC on the 30th. And one of the things that usually happens around this time, if they're still tracking that, as I'm saying, is they should be wrapping up the go-no-go poll or propellant loop. And so around this time, that's when the launch reactor usually says whether they are go or not. If they are go, then they gave essentially the abort instructions and things like that. And then at T-minus 35 minutes, that's when propellant load starts. An automated sequence where RP1 and liquid oxygen begins loading on the first stage, and then on the second stage they only start loading RP1 first, and then about 15 minutes later the RP1 load on the second stage will wrap up, and they'll begin the chill down of the liquid oxygen line to the second stage ahead of that stage 2 liquid oxygen load start at T-minus 16 minutes. So that's more or less what we're looking forward to in the next few minutes. Of course, unfortunately, we don't have any access to those loops from Mission Control, and so we're going to have to wait until we see some confirmation from SpaceX, or we see some kind of activity from the booster, namely frost, which usually happens about 4 or 5 minutes into that propellant sequence. So about T-minus 31, 32 minutes, maybe T-minus 30, depending on the humidity and other weather conditions, but yeah.
A lot to keep an eye on in the next couple of minutes to see if they are underway. And again, once they start fueling, they are committed to that T0.
Yep.
So in terms of everything proceeding, a lot of it comes down to the rocket. A lot of it, of course, also comes down to weather. Julia, how's the weather looking?
You know what, Sawyer? It is a gorgeous day. Our little polar vortex has pushed out, and that also means that we have almost no clouds in the sky. And when I say almost no clouds, I mean like I see 2 wispy, long somethings in the sky. Otherwise, the lagoon is calm, and the temperature is roughly 65 degrees, and it's gorgeous. So as far as weather goes, I don't see this at all having any constraints on this launch.
Neither does the 45th Weather Squadron, giving it a 95% chance of a go condition weather-wise for launch. At Games, I'll just say that, is asking, does SpaceX remove anything from the booster before an expendable launch? And the answer, Alex, is yes.
Yeah, they remove the landing legs, the grid fins, and it's not because, it's extra weight. It's just because they don't need it, right? If you're not going to land it, why would you keep the legs and the grid fins, right? In fact, what they do is the grid fins need to be, they are inserted into some of the hardware inside of the intrastage. So what they do is the access panels to be able to install those grid fins, they are covered. And so, if you were to look close to the intrastage, you will see that it's closed out. They also remove the RCS pods and things like that, like those thrusters that they have in the intrastage to be able to maneuver once it's in space and before it's through the atmosphere. And so those things get removed, and I will bet probably also the relight capabilities like the T-tip canisters and things like that probably get removed. Like if you don't need it, why would you have it, right? And why not? Maybe you can use it on another booster.
Yeah, exactly. They can mix and match parts between these boosters, right?
Yeah, and we've seen that not just visually, but also like from SpaceX. We've had confirmation in the past that even the engines, for example, get removed and then they fly another booster for a bunch of other times. And so sometimes it's very likely that some of the engines might actually have more flights on them than the airframe itself, right, of the booster. which is quite funny.
Quite funny indeed. We are under that 35-minute mark now, so we'll be keeping an eye on the booster very closely to see if we can start seeing any of that frost forming. If we do, we will indeed know that fueling is underway. What's that happening? Here's an interesting question from John Cook. They're saying, how many gallons of water does the water tower hold? You can see it to the left there of the fixed service structure, that black tower. There is the water tower, which during the space shuttle program was 300,000 gallons of water, if I recall correctly, which I believe is just over 1 million liters of water. Julia, that is quite a lot. What do they need all that water for anyway?
Oh, well, that water is kind of important to the protection of the launch pad itself, actually. Without that water, for sound suppression, SpaceX wouldn't be able to turn the pad around as fast as they do. That is the primary use for water, and also what kind of generates that steam plume that we see at launch.
Yes, we always look for the steam, which gives a good indication of engine ignition, and it drains that water very quickly. That thing can empty in about a minute, so that is the water tower, and sometimes people actually see water leaking out of it as it kind of tops off, and that is totally normal. Let's take some more of your questions here. Reminder, if you have any questions, you can tag us at NASA Spaceflight, and we will do our best to answer as many of them as we can. One of the things I want to talk about, Alex, is we've mentioned that, it has different bands on it and things like that. It has some cool deployment mechanisms for, like, the KU band antennas to be able to pop them out, right?
Yeah, there's a lot of these systems, of course, that need to be deployed while in orbit. One thing that I would mention, though, we now have confirmation from SpaceX that they are underway with that propellant load. And in fact, as I was saying this, I'm looking at the booster, I'm seeing some frost already building up on the booster liquid oxygen tank. But yeah, this is one of the things that they have included here, where there's a lot of these systems that are able to do, the X-band, the ultra high frequency bands and everything. It's really important to have that capability.
Yeah, and these will have, it's kind of like a little bed that folds out, and then they can take individual KU band antenna and steer it in whatever direction they need. So it's kind of like a fold-out bed with different antennas you can point on it, which I think is just so cool.
Yeah, and the solar panels are huge. If I'm not mistaken, it's something like 40 meters or something like that in span from one tip to the other. Like, it's a huge satellite once it's deployed out there in space. I'm kind of, I think if they wanted to, like, make it even more peak, they should have built one of these, like, giant expandable antennas like they do now. For some of these communications, where the antenna expands to like 50 meters wide or 80 meters wide. It's crazy. Kind of wish they will have done that just to, maximize the potential. But hey, maybe NG3 or new generation or something.
New generation. I mean, these are supposed to last 15 years of operational lifetime.
Yeah.
So that may be a little bit.
Yep.
Coming up now on 30 minutes to go until launch of SpainSat NG1. We are getting closer, and I do want to thank RC Horseman really quickly here for gifting 10 Red Team memberships. Very much appreciate that. One question that I saw, a lot of people are wondering, will I be able to see the launch? Where can I see it? First off, here's a quick update on the timeline, by the way. As mentioned, we are now into that propellant load. SpaceX confirming that. So, liquid oxygen and RP-1, rocket propellant 1, in refined form of kerosene are being loaded into stage 1, and stage 2 getting that RP-1 load. That, of course, continuing till the famous T-minus 20-minute, 20-second vent, as we like to call it here. The locks chill down in 9.5 minutes. So, lots of good stuff still to come. But Julia, with this launch going due east, who should be on the lookout to potentially be able to see tonight's launch?
Well, Sawyer, I believe if you were to go outside during launch, you would see it as far south as you are. People would see it at, well, probably up in the Carolinas. Well, potentially Carolinas, for sure northern Florida. And if you're out in Orlando area right now on vacation, if you look east, you too will see this rocket going out over the ocean.
There you go. Things to keep an eye out for. And again, this booster will not be returning. So this is an expended booster on its final flight here. But Space Marshal wondering, and we can say yes, do they recover the fairings? Alex, how does the fairing recovery process work?
That is a great question. So once the fairings separate about 3.5 minutes into flight or so, usually that's more or less the normal time. The fairings then have RCS thrusters that they can use to be able to orient themselves while in space, because it takes a while until they re-enter the Earth. And when they re-enter the Earth, they need to be in the right orientation, namely the curved part needs to face down, and so they use that sort of like a surfboard kind of thing to surf through the atmosphere as they re-enter through. And once they go through all of that, through that re-entry, they slow down, to subsonic speeds, and then they pop out a parachute, and then they splash down in the ocean. Out there in the Atlantic Ocean, it's going to be for this mission Bob, one of the 2 fairing recovery vessels that SpaceX uses in Florida to recover these fairings. And so in a couple of days, check out Space Coast Live, because you're going to see those fairings coming back home.
Yep, we have a 24/7 live feed, Space Coast Live, where you can see everything going on at KSC, parts of Cape Canaveral Space Force Station, and Port Canaveral, where boosters and fairings and all the different things come in. And there is a quick sneak peek at it at Space Coast Live. Well, live as you're seeing it. So that is always on, so make sure to check that out. And spoiler, there may or may not be a new camera that was installed at the port just today. So keep an eye out for the debut of Fleet Cam 2 now on SCL.
And you know what's funny about that, Sawyer, is Fleet Cam is the OG of our robot fleet. And all of these cameras went to Starbase, and our OG is finally getting a friend now.
Yes, that was our first major live feed, was the camera just looking at the fleet in Port Canaveral, so Fleet Cam 1. And yes, it finally has a friend. Bob Ross would be happy, because everyone needs a friend. Here's a question from Henry Slack. And Julia, I'm going to put this one to you. They're asking, why can't Falcon 9 hold like New Glenn can, and, well, did a lot? Do we still have you, Julia?
I totally and completely missed your question. Like, phone blacked out on me. Repeat the question for me, Sawyer.
Henry wanted to know, why can't Falcon 9 hold like New Glenn can? Well, did a lot.
Well, that has to do with the fueling. Different fuels have different requirements, and SpaceX super chills their fuel. And with that super chill, it means you can't hold. You would have to totally detank and retank. And that's just the process that SpaceX chose to be able to do rapid fueling.
Oh, yeah. I mean, it is cool to super chill propellants, but it is not super chill when it doesn't launch because of that.
Right. Now, if you want to say technically, SpaceX could push into a window if they haven't begun the fueling process. How about that?
There you go. I was just trying to make a terrible pun at the end there, that's all.
I tried to stop you.
You know that's not going to work. It's me. I'm being told we have a surprise for Kevin Michael Reed in the back channel. What is our surprise here? This, I believe, is our fancy schmancy tracking rig that we have now. And I believe we can see the back of the head of Gage, who is at the Cape. Spoiler! Yes, surprise, you're on air! Come say hi! There you go. Perfect. Gage coming in with the wave, listening in, and the thumbs up. Did good with the first launch. The first launch went off on time, and excited to see your tracking here. For those who don't know, Gage, one of the awesome operators over at Space Coast Live, who happens to be at the cave now, will be doing the tracking in person as opposed to online. So everyone in chat, shout out to Gage. Cool little surprise. Alex, I did not jinx anything.
You totally did. You said that the first launch went well, and you just made the right conditions for the second one to not go well.
But that one already happened. It's not like I'm saying something will or won't happen in the future. I couldn't say that did happen. It is truth. It is fact. It is history.
Let's go at least 23 more minutes and see what happens.
Preferably 23 minutes and 40 seconds to getting past ignition and liftoff. That would be extra nice. Also extra nice is L, who says Sawyer and Alex, best duo. Thank you, L. Now I gotta ask Alex, this may be a weird question, but given that this is a SpainSat, is there kind of a sense of pride with you or with the country in general of getting their own, getting a satellite like this up and running?
Well, the only pride that I have is that we chose the correct launcher. The last time that we had a very expensive satellite on a rocket, it was a Vega C, and it kind of, it was delivered, not to the right orbit, not even into orbit, delivered to the Atlantic Ocean.
So just the excitement that it's launching on a Falcon as opposed to, oh, cool, Spain getting into this more.
And it's not the first one, of course. We've had a few, especially smaller ones on transporting missions, but also big ones like the SpainSat 30W6 mission, which ironically was also expendable. But also we had the PATH satellite that was also a military satellite launched on Falcon 9 from Vandenberg, and that one, I'm mostly sure a lot of people in chat maybe remembers this, that one had 2 ride shares on board with that military satellite from Spain, and that was Tintin A and Tintin B from the Starlink prototypes. So yeah, that was a long time ago that happened, but it went into orbit, it was deployed, it did the thing, right?
It does the thing.
Yep, and it's actually it's actually part of the Histosat company as well. Like I talk about the X-Star EUR satellite and the SpainSat satellite. The 2 original satellites are going to be replaced by SpainSat NG1 and NG2. They also made the PATH satellite and also the other one that I was mentioning that was lost on a Vega satellite, the CEOSat Ingenia satellite. And so yeah, at least we chose the correct launcher in my opinion. I'm mostly sure of its reliability.
Yeah, a lot of international satellite manufacturers have chosen Falcon 9 as one of their launch vehicles. And at least, I guess, it launches because they could have put it on an Ariane rocket, but that would maybe launch 6 years from now?
In fact, because it's now part of the news as well, I've seen interviews with the CEO of Histosat saying yeah, we could have launched it on Ariane 6, but it's not launch enough. So it's we want a launcher that has some past track at least, some heritage, I guess, some launches on its belt.
Yeah, you want something that's reliable, like the fact that it's pretty reliable that at T-minus 20 minutes and 20 seconds we get this that you see on your screen there, the T-minus 20 minute vent, aka the best vent. Julia, what is this vent?
This vent is, this is routine, as you can tell, Sawyer predicted it, but this vent is the topping off of the first stage fueling, and now we move into closing out second stage, which will be a vent that I'm sure Sawyer will be predicting not too far down the road.
Yeah, this one's actually the second stage. Yeah, this is the second stage, RP1 wrapping up and purging the lines ahead of time. So They'll get those lines cleared out, get all of the RP1 out of there, and chill things down a little bit more, because RP1 is a little bit closer to ambient temperature than the liquid oxygen is. It's still cold, but now needs to get even colder. So here comes the dur in the colder. That should then begin with the stage 2 LOX load in a couple of minutes, and yes, we will have one more vent as they wrap up fuel load in both of the stages later on, so we will have to keep an eye on that. And as we keep an eye on this mission in particular, this is a Falcon 9 rocket at Launch Complex 39A at the Kennedy Space Center in Florida. On board is SpainSat NG-1, or New Generation 1. This is a new type of military communications satellite that is primarily for Spain and other NATO members that will expand their coverage using X-band, Ku-band, and ultra-high frequencies all across North America, South America, Europe, Africa, the Middle East, and parts of Asia. As you can see, it is quite a big satellite. Alex, how heavy and big is this? And can you talk a bit about the bus that it's built on?
Yeah, so the satellite, without all of the hardware deployed, is about 6.7 meters tall and 2.7 meters wide. And at launch, it's about 6,000 kilograms in mass. So it's quite a heavy satellite, and that's why the booster is going to be expended on this mission. This is based on the Eurostar Neo platform that Airbus builds, essentially, for some of these satellites. You know, these big satellites are usually that Eurostar Neo platform. And one of the things that it has is that it uses ion thrusters to be able to put itself into the final orbit, which means you have a higher higher efficiency, right? And so you don't need as much fuel, and so that mass instead can go into payloads like, you know, what we're talking about, ultra high frequencies, X-band, K-band, Q-band, and so you have a lot more capability in a very similar size to a conventional satellite that may be using hypergolic propellants to be able to go into their orbits. But that also means it's going to take a while to get there, because ion thrusters, they are very slow, and you know, it's a tiny amount of thrust, but a tiny amount of thrust over a long time, and it's a very high efficiency engine. It means you don't need as much fuel. It takes time, but again, if you're not in a hurry, you can kind of get there and much more efficiently. In turn, you can carry more payload on your satellite.
Exactly, and this is there to help supplement and eventually replace the older batch of satellites that are up there. So this will be going to geostationary orbit, so it will stay stationary over a certain point on the Earth. This one will go into the 29 degrees east position, as it's known. There will be a second satellite, also set to launch this year, and that will go into the 30 degrees west position. That one will replace the original SpainSat, this one replacing a satellite called XTAR EUR, E-U-R, so I'm guessing Europe there. Julia, this booster, I hate to keep bringing it up, but this booster is about to make its final flight, right?
Indeed it is. It's a rare, for those who are just recently joining us, this is a rare expendable mission. This will be the 21st flight of booster 1073. So as you look in the sky and follow this launch, although it is a clear night, and often we would see that reentry burn as it comes toward the drone ship for landing, tonight we will not see that, sadly. Which means we are recovering part of this booster. Bob is downrange to recover the fairings, and as we discussed earlier, there are no landing legs, there are no grid fins, because they are not needed for this mission. So in theory, we can say a little bit of 1073 will live on.
Yes, and 1073, the rare, starting off its life with a Starlink launch, but also launching a whole bunch of international missions, including Hokuto R for Japan. You had Amazon's Nexus, which was for Hispasat. So a lot of international missions carry on this particular.
Also Spanish.
Also Spanish. Yes, exactly.
Yeah, that was Spanish
Soraya,
too.
GS. So a lot of cool international flights flown.
Comme vous pouvez le voir chez moi, il fait 22h19. En France, il devrait être.
Final one, number 21.
Il devrait être à peu près 1h, 2h du mat.
Failure, the 429th orbital flight in Falcon 9's history, and the 102nd SpaceX launch here from LC-39A at the Cape.
Il reste à peu près 14 minutes avant le décollage. Nous sommes sur l'écran d'attente de SpaceX qui est normalement d'à peu près 5 minutes.
Tonight's trajectory is due east. That means if you are anywhere north, south, or west of us, you should be able to see this rocket launch if you step outside and just simply look toward the east. If you're on the coast, you're just going to look at the Space Coast across the lagoon and see that launch. And Sawyer, I want to tell you something. This photographer forgot something very essential. She forgot to
You're looking at a live view of
watch a launch like the locals do.
8:34 p.m. Eastern Standard Time from
it's called How to Watch a Launch.
And
we can tell
Désolé, j'ai quelques problèmes de connexion.
depending on what is launching
here
and
at
where it's
SpaceX in Hawthorne, California. Today we are launching the SpainSat NG-1 satellite to a geostationary transfer orbit on behalf of our customer, SpainSat. SpainSat is a government satellite operator and services provider operating secure communication satellites, synthetic aperture Earth observation satellites, and maritime monitoring. SpainSat has provided Earth observation services with radar technology through the PATH satellite, which SpaceX launched on a Falcon 9 back in 2018. SpainSat NG is a new program developed by SpaceX to improve the secure satellite communications and defense capabilities of the Spanish government, its allies, and international organizations, including the European Union's GovSatcom and NATO. SpainSat will cover an extensive area that ranges from the United States and South America to the Middle East, Africa, and Europe, reaching as far as Singapore. Now we're currently at T-minus 11 minutes 25 seconds and counting. We're looking good for an on-time liftoff. However, if for any reason we are unable to launch today, a backup opportunity is available tomorrow at the same time. But the good news is Falcon 9 is healthy, the range is ready to support, the weather's been good all day and continues to look outstanding. We're not tracking any concerns for launch in just over 11 minutes. And with that, let's take a look at today's Falcon 9. The two-stage Falcon 9 you can see on your screen with its payload fairing is 70 meters or 229 feet tall. When it's fully loaded, it'll hold just over 1 million pounds of propellant, which the vehicle will burn through in less than 3 minutes after liftoff. Propellant loading did begin on time at T-minus 35 minutes this evening. The second stage fuel tank is fully loaded. The first stage fuel tank loading will complete at T-minus 6 minutes. Liquid oxygen loading is underway on both stages. Now, our payload today is safely enclosed inside of the 17-foot diameter payload fairing, which is a structure called out at the very top of the graphic. It's made of a carbon composite material, and the two sides of the fairing form a clamshell around the satellite to protect it during ascent. Now, the fairing halves are then separated at about 3 minutes and 40 seconds into today's flight, they'll be recovered from the ocean for reuse. Now, the fairing half supporting today's mission are flight proven. One half is flying for its 8th time. The other half is flying for its 5th time. Now, below the payload fairing, you can see the second stage. That's the part of the rocket that will take our payload to its destination orbit today. The second stage will ignite its single Merlin vacuum engine, or MVAC for short, at 2 minutes 50 seconds into flight. It'll relight a second time before we deploy the satellite. Below the second stage, you can see on the graphic the first stage. And it starts with the black inner stage, which is part of the first stage booster. The carbon fiber inner stage is that distinct black color. That's the thermal protection system on the outside of the inner stage. Now, at the bottom of the first stage are the 9 Merlin engines. You can't see them in this view, but they are obviously at the bottom of the first stage, and they'll propel Falcon 9 off the ground up to the thinner parts of Earth's atmosphere. Now, the first stage is designed to be reflown with minimal refurbishment between flights, with today marking the 21st flight for this particular booster. However, due to the performance required for today's mission, this will be the final flight for this Falcon 9 first stage. During its 21 missions, this single first stage has launched a lunar lander to the moon, critical supplies and research to the International Space Station, over 400 Starlink satellites to orbit, and much more since its first launch in May 2022. Finally, alongside the vehicle, the large truss structure you see, that's part of the transporter erector, what we call the TE. We use the TE both to roll the rocket out to the pad and then to raise it to its vertical launch position. At liftoff, it will retract in order to clear the way for Falcon 9's ascent. Now, while the countdown continues coming up on T-minus 8 minutes, let's find more about the satellite we're delivering to orbit today, SpainSat NG-1.
The SpainSat NG program will provide a sovereign, secure communications capability for government missions, with 2 new generation satellites based on Airbus's Eurostar Neo platform, which is developed under the European Space Agency's partnership projects. The SpainSat NG program is under the responsibility of Istisat.
Yeah, and this one is going to 29 degrees east.
Istisat is an international service provider of X and military Ka-band for government and military applications. Our role in the program SpainSat NG is to be the customer of the full program, including the space and ground segment, the launch, and the operation and exploitation of the satellite during 15 years lifetime.
What's unique about the SpainSat NG program is the PASIS 3 funding partnership model.
PASIS 3 is a financial scheme to develop the most innovative elements of the SpainSat NG payload with the support of the Center for Technological and Industrial Development, CDTI, in a framework of a private-public partnership between the European Space Agency and Istisat as an operator of the sat.
The most innovative element of the payload is the X-band active antenna system, comprising both receive and transmit antennas.
Something as complex as the DRA's antenna in X-band, an active antenna that can move the pins electronically and can configure the pin electronically without any movement, is what makes this satellite the most advanced one in Europe today.
These active antennas are at the cutting edge of new technology, with beam hopping and geolocation capabilities enabling artificial intelligence, big data, and the Internet of Things on the ground. The antennas are being developed by Airbus, which is leading a consortium of 5 Spanish space companies.
The active antennas are already in production. Actually, they are in the assembly, integration, and test phase. That is the last phase before delivery of the antenna. It's done in Barajas site in Airbus Defense Space in Spain, and it will be delivered to Toulouse.
For SpainSat NG1, the mating between the communication module and the service module has taken place in Airbus facilities in Toulouse. This was the first step of the final satellite AIT phase.
The SpainSat NG program has been a very good example of institutional and industrial collaboration. In the industrial part, it has been a very good collaboration between the two main industries in Europe, being Airbus and Thales Aerospace, including all the Spanish industries in this important program.
Airbus works to safeguard Europe's citizens and strategic autonomy. Through SpainSat NG, it will provide secure, resilient and flexible communications for those who keep us safe.
T-minus 4 minutes, 26 seconds counting. We just heard the call out, Strongback lower has begun.
Il reste 4 minutes 30. Désolé si ma voix est un peu plus faible que tout à l'heure. C'est parce que là, je suis un peu fatigué. Et quand même presque, il est 22h30 chez moi. Bon là.
At this point now, the Strongback should be retracting there. You can kind of see it is indeed backwards a little bit.
And you can see the arms coming open now. Next up will be retract of the Strongback. Now the transport erector we talked about has two components, the Strongback that runs alongside the Falcon 9 and a launch mount underneath. The launch mount under the Falcon 9 has the 4 hold downs that release at T0. The Strongback along the side is hinged to the launch mount, and it will rotate right now about 2 degrees away from the vehicle, and you can just start to see that motion beginning. Now at liftoff, the Strongback will then move to a position 45 degrees away from the Falcon, and that clears the way for launch of the launch vehicle.
And the rocket are as short as possible.
Completing the recline. Now at this point in the countdown, both the first and second stages are nearly fully loaded with 1 million pounds of the kerosene fuel and liquid oxygen. First stage loading should complete here momentarily. We're waiting for the call out. And then about a minute later, second stage of liquid oxygen loading should complete.
To the vehicle, but also data to and from the vehicle, as well as the conditioning needed for...
Now the white clouds...
Stage 1 LOX load is complete.
Stage 1 LOX load complete. We're on time. We're down to one more tank to finish loading. Stage 2 LOX. The white clouds that you're seeing around the vehicle, they're formed as the chilled gas vents overboard to maintain pressure in the tanks as needed. Current temperature at the launch site's a balmy 63 Fahrenheit, 17 Celsius. And when the gas meets that warm Florida air, it condenses the moisture in the air and it forms those clouds. As we wait for T-minus 2 minutes and the start of the second stage LOX closeout, a few more things that'll happen in the last part of the countdown. At T-minus 60 seconds, Falcon 9 will be in startup. That means the rocket's autonomous internal flight computers have taken over the launch countdown. There are computers on both the first and second stages.
Stage 2 LOX load is complete.
LOX load complete on second stage. That means the 1 million pounds propellant is completely loaded now on both the first and the second stages. Next major activity is going to come up at T-minus 1 minute 30 seconds. That's going to be the ground gas closeouts. We'll begin venting pressures in the Strongback overboard, make sure everything is drained in preparation for launch.
Le deuxième étage est à présent rempli. Dans 30 secondes, nous aurons le start-up.
There we go. The gas closeouts have begun. Next major event will be T-minus 1 minute. As I mentioned, the Falcon flight computers will go into startup. One comment, I mentioned there were flight computers on both stages. During ascent, the second stage flight computer is the master. As we count down at T-minus 2 seconds, we'll begin the Merlin 1D engine ignition sequence. The flight computers will command the hold downs to release at T0.
Voilà. Il reste une minute, c'est le start-up.
Falcon 9's gone into startup. The flight computers are now controlling the launch vehicle. Falcon 9's looking good. SpainSat is ready to go. Falcon 9 team's working no issues. The weather is excellent. The range is ready.
Director, go for launch.
And the launch directors go for launch. Let's listen in to the flight of SpainSat NG1.
Reste 30 secondes. 20 secondes.
just about 10 seconds
T-minus
from
10, 9,
You can now see
8,
the rainbows that
7,
water suppression at the base
6,
of the rocket starting
5,
up.
4,
Next, we'll keep an
3,
eye out for ignition.
2, 1, ignition, liftoff. Go SpaceX, go SpainSat NG1.
G1.
Vehicles pitching downrange.
Stage 1 propulsion is nominal.
T plus 30 seconds, Falcon 9 has successfully lifted off from Complex 39A at Kennedy Space Center. We can hear the characteristic rumble as the first stage heads into space.
Voilà là,
We're
le
throttling down
revoilà.
right now in preparation for max Q. Good call out,
Les
power
fusées
and
Falcon
telemetry
9 viennent
nominal.
s'élever dans le
Report to
ciel.
avionics.
On annonce bientôt à Max Q, lorsqu'il y aura le plus de force G exercée sur la fusée. Voilà, donc là, Falcon 9 est supersonique.
And we have throttled back up to power.
Et là, c'est le Max Q. Et là, vous avez pu le voir, il y avait le nuage là, le sorte de truc là, le sorte d'anneau qui se forme lorsqu'on passe le mur du son.
Max Q.
And we've heard the max Q call out. Continuing on the timeline, everything looking good. The rocket typically will need to go 17,000 miles per hour horizontally in order to get into orbit and avoid being pulled back down to Earth. To help go from vertical to horizontal, the first stage performed a pitch kick just after liftoff, about 10 seconds into flight, or what's also known as a gravity turn. The engines gimbal a small amount, and that slowly turns the first stage from going straight up to going horizontal with the help of gravity, and eventually we will be roughly horizontal to Earth as we achieve orbit. Now you can track the progress to orbit by keeping an eye on the left side of your display. That's showing the first stage velocity and altitude, and then we'll have displays for the second stage as we get past stage separation. Now we're going to have coming up in about 30 seconds the start of the typical 3 quick events. Main engine cutoff, or MECO, you'll hear the call out. We'll shut down the 9 Merlin engines on the first stage. The pneumatic system, the stage separation pushers will then push the first stage away from the second stage for stage separation, and the MVAC-D engine will ignite, and then fairing separation. For now, let's listen and watch for the events.
Any second, we should see main engine cutoff.
There it is.
Extinction du booster.
Next up will be first and second stage.
Séparation.
Confirmed.
And keep an eye out there. That looks like ignition of the
Stand back,
Merlin
ignition.
vacuum upper stage engine.
Et
So we have
allumage
PS1. Exactly what we
du
wanted.
deuxième étage.
We say farewell.
And there you heard and saw those events that happened back to back to back. We had main engine cutoff, stage set, and second stage engine start number 1, SES-1. Right-hand side, you can see the altitude and the velocity of the second stage. So far, I want to remind folks who might be waiting for it, as we talked about earlier in the webcast, the first stage will not be recovered today. You may have noticed that we removed the landing legs and the grid fins to decrease the mass of the stage. That'll provide the performance needed to put the 6 metric ton spacecraft into orbit.
Alors pour ceux qui n'ont pas compris, le premier étage ne sera pas récupéré cette
But now
fois-ci.
we want to say to the first stage,
Fairing separation confirmed.
There's fairing separation. Look at that.
fairing separation on time.
Yeah, you can
And for first stage that is on its way back to Earth, not for recovery, farewell, and we thank you.
Yes, those are those 2 fairing halves.
Now the fairing halves that you just saw separate from around the SpainSat NG-1 spacecraft, we'll be attempting to retrieve those halves once they fall back to Earth using our recovery vessel Bob. Now the fairings will orient themselves as they come back down with gas thrusters for entry into the atmosphere, and as they near the ocean, each fairing half uses a gas-powered deployer to release a parachute. The fairing computer will send commands that steer the fairings to the ocean landing, where the recovery vessel Bob will attempt to recover them. Now we've got a few minutes until our next major event, SECO 1, which is where we'll shut down our MVAC-D engine on the second stage in the parking orbit.
Stage 1 FTS has saved.
Coming up on 5 minutes, everything continuing to look good. You can see the orange-red glow of the niobium alloy nozzle extension on the second stage engine. Very standard for the MVAC-D engine. Five minutes, everything continues to look well, look good. Now you'll notice the speed continuing to increase on the display for stage 2. That speed is obviously increasing. That's because the acceleration
D'ici 2 ou 3 minutes, on aura le cycle 1. Et après le cycle 1, donc l'extinction de l'étage supérieur. Je finirai le live parce que là je suis plutôt fatigué pour rester jusqu'à la séparation. Désolé, hein. Si un jour je suis en pleine forme, même jusqu'à minuit, tiens. Là je pense que je pourrais faire un live qui dure plus de 2 heures. Je pense pas que je pourrais rester jusqu'à la séparation.
T plus 6 minutes, continuing to look good on the second stage. SpainSat NG1 attached to the top of the second stage. We'll see some views from the forward-looking camera
on a nominal trajectory.
A little later on. It's the GNC, the Guidance, Navigation, and Control Engineer, calling out the nominal trajectory for the stage. Six and a half minutes into flight, continuing to look good on the burn. Next major event's going to come up a little bit after 7 minutes. We should hear a call out of terminal guidance on the second stage as we begin to get ready for shutdown at T plus 8 minutes and 1 second. Call out from GNC. Second stage flight computer is now moving into a state where it's preparing for that second stage engine cutoff. We're calculating the velocity required to get to orbit. You have to understand how fast you're going horizontally as well as away from the Earth. And then we have to come up with the commands that are going to go to the actuators so that we can command pitch and yaw to make sure that the second stage aims itself, so to speak, to achieve the desired orbital parameter. Final velocity for this first burn is aimed for about 7.5 kilometers per second. That's going to be just under that 17,000 mile an hour figure we need for a low Earth parking orbit. And 7.5 kilometers per second, that is the rule of thumb for the velocity you need to get into an Earth orbit when you're launching eastwardly, for example, out of Kennedy. Shutdown of the MVAC, we're going to wait for guidance to tell us how the orbit looks.
Nominal orbit insertion.
And confirmation, nominal orbit insertion. We're through second stage engine cutoff number 1, SECA 1. We're right where we want to be in orbit. Now, the second stage, and we've got another nice view looking forward from the payload attached bearing up at SpainSat NG1. We'll have more views as we go through the webcast, but for now, we're embarking on a coast phase on the second stage. The spacecraft still attached. Following this coast, we will relight the MVAC engine for a second time. That's going to happen around T plus 26.5 minute mark. And then about 4.5 minutes after that, at T plus 31 minutes, we will actually get to spacecraft separation. For that, we're going to halt the live commentary for a while. We'll be back in about 16 minutes at T plus 25, but we'll leave you with the visuals from space.